disturbing. And just cancel the m squares. I mean, I desperately always try to make a huge deal out of this thing. I mean, it is very human to hope something like that would happen, but of course, why can't I not do that? Why can't I just kill these? Yeah, division does not cancel subtraction or addition. There's no way. So a couple students is too many. I think the rest of you did it okay. You knew to try to factor. Maybe the factoring went wonky, but it's better than just killing stuff that you can't kill. Division is not the right weapon for that. Need some dragon class. Okay, there you go. Anything else from the test before I get into new stuff? I already asked you a few times. Yes?
Can you go over what distance recon at number 8?
The big thing with number 8, the most commonly misunderstood thing was same time. So a lot of you guys got the chart created, and then you're not sure what the hell to do with what you just did. But it says in the same time. So that means whatever you got for one time is equal to what you got for the other time. So a few people are trying to add them together and make 8 or something. You're like, this equation's too easy. It's got to be something more disgusting. No. It's when it says same time and you have expressions for the two times, you just set them equal to each other. That's the thing about mathematics that people don't really get, is that the equation you set up has to make physical sense for so many problems. So yeah, that one was kind of rough. There were, there was a lot of different types of problems, but that was one common thread, was not knowing what to do with it. Anything else from that? Okay. Can I actually turn this guy on? Yes?
I just forgot how to do the interval for 5C. The order.
Oh, well, so, okay. Just so I don't do your problem, let's see. What if I had this here? How do I represent that in interval notation? So one piece is going to be, careful now, and what goes on negative infinity or infinity always? Parenthesis. You never put a bracket. I like saying that because it's funny. If you put a bracket, that means you can get there and pick it up. Now I can get to negative 5. I can find it. Can you find infinity on this thing? No. So if you put a bracket on there, I want you to come see me and show me. Get infinity and show it to me, right? And I think that's what was in the suitcase in Pulp Fiction. But found infinity. Up to negative 5 with a bracket, right? What goes in the middle? Yeah, the or symbol. That makes sense for that problem. It's or, yeah. And then it goes from negative 1 to infinity. Odd, guys. Chris, did you get the email about the assessment test and stuff like that? I'm going to check it. We had a big discussion.
Is it about that math thing that if you, okay.
Math 108,
yeah.
if you do blah, 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 there's recent changes.
Okay.
All right, so let me know. We had a discussion. Let me know if you have questions.
So, am I supposed to do it?
You can do the assessment test. See me after class.
Okay.
Oh, yeah, sorry. Is that cool? Okay. Good Lord, it's like a beach towel. All right. Anything else for the test before we get back into other stuff?
How would you do the bonus question?
Which one?
Number 1.
Oh, okay, this is cool.
That was simple, but it's not.
Watch this. This is greater than 0, right? Okay, now, there's a few different ways to do this. It's bonus, so I could say if you knew what this looked like, you could actually figure it out visually. for what x's is this 0? I think it's 4x there, right? Not 4? Is it 4?
Yeah, it's negative 4x.
Okay. Where does this equal 0? I know it says greater than 0, but if I find where it equals 0, then I know it's got to be outside of there. So where's this thing equal 0? At
Oh, at x.
0 and 4. So it equals 0 there. And now watch, this is kind of cool. And again, this is bonus. What would this thing look like? It would look like a parabola, right? I know we haven't officially talked about it. So you can think about if it goes through 0 here, and it looks like an up parabola, then where is it going to be greater than 0? Above 4 and below 0. That's where it's above the x-axis, because that's 0. I like it. There's no way to kind of do this directly otherwise. Yeah. We are going to talk about these kind of problems and how you can do it computationally, but you got to set up a different looking thing. Yeah. I just like to put that bonus down there just to see what people do.
At first, I thought, you know how like there's an x squared, and you always subtract it to get it equal to 0, and then you just factor it. I thought it was gonna be like that, and then I figured out like
No.
it's not really.
Yeah, it's not quite like that.
Yeah.
Okay. Another way you could kind of tease this out is, do you see how I've written this as x times this? And the only way for the result to be positive is if x is positive and this is positive, or x is negative and this is negative. Then the product would be positive. I mean, there is a way to do it that way too. That's enough of that one. Give you some ideas. Okay, so let's get back into, we're getting into chapter 10 now. Oh yeah.
How much is the extra credit for?
Each bonus question is worth 2 points.
I was talking about the homework.
Oh, so what I do with those is, if you've done all the homework plus you do those, your homework average goes up from 100. So I gotta base it on how many total homeworks at the end to see how much that may be worth. Normally it's worth like 1 homework. So if you do all, so if you miss 2 homeworks and you do those, it'll replace those in the grade. If you do all the homework and you do those, your homework average is above 100. Yes. Okay. So let me start off. We talked a little bit about roots, what I'm going to call radicals. We're going to start with the one that we know the best, the square root. But let me ask you this first. Just the idea of roots. Don't mean to move it. See the movie, that's a good movie. Can somebody just tell me, what do I square to get 9? And if you stop at one answer, you're wrong. It's 3 and negative 3. I like it. So the roots of 9, the square roots of 9 are 3 and negative 3. But when I write this symbol, that is understood to be the positive root. That symbol is called the principal square root. I think it's spelled. So we understand the idea, any number except for 0. 0 is the only one among the 0 or greater numbers that has only 1 square root, of course, 0 times 0. So when I write that symbol, I mean the positive root. So if I wanted to get the negative root, I'd have to put a negative on it. So a square root, when you do a square root, the answer has to come out to be positive. Because it's defined to be the principal square root. So that's the difference between this equation that has 2 answers. Why does it have 2 answers? Why does it make sense? Second power, 2 answers. Versus this problem, which has 1 answer, because by definition it's the positive answer. I like it. Okay. So, what if I had, so let's just try a few things out. Let's see what you guys know. What is the square root of 121?
11.
11. Why?
11 times
Because
11
11 times 11 is 121. I like it. Right. So, like I said last time, what number is understood to be here? A 2. I like it. So that's why the question, and so this is an interesting symbol. We kind of inherently know what the question is asking, but what it's asking is, what does it take 2 of to multiply to be this guy? That's why the answer is 11, because it takes 2 11s to multiply to be that. So let's step this up. What do you think this is? What is that symbol asking you? Musical answer, I like that.
4
Not sure how to
times
interpret.
equals 16. 4 times something.
What number does it take 4 of to multiply to be 16? So the question doesn't change. It's just this number could change. So what do you multiply by itself 4 times? 2. 2 times 2 is 4 times 2 is 8 times 2 is 16. So the answer to this is 2. So the larger the root, the more it cuts a number down. Because what's the square root of 16? The square root of 16? 4. Bigger than 2, of course, because this cut it down by 4 and this cut it only like half multiplicatively. Let me throw that out there. I'm going to say stuff like a square root cuts a number in half. But half of 16 is 8, Jeff, but when I say that I mean multiplicatively. 16 is 4 times 4, half of that is 4. You guys with me a little bit? Okay. I know you guys know square roots. I'm not trying to mess that up. I'm trying to make it a more general way to look at it. Let's look at, all right, here we go. This is kind of related to what we talked about here. Here. What is the square root of x squared?
X.
Sorry, man, you fell into my trap. Why isn't the answer, why can't it always be x? Because the square root answer is supposed to always be, you can do it. The square root answer has got to always be positive. And what could be true about x? Could be negative. So what's going to save my ass? What makes this thing always be positive? Yeah. So the absolute value has purpose. Because the absolute value has 2 different outputs based on what the input is. And the square root of x squared, now watch, let's try this out. What's the square root of 7 squared? You don't even really have to think about it. Square root of 7 squared is 7. See how the square root and the square kill each other? But, what's the square root of negative 9 squared? It's not negative 9. It's the absolute value of negative 9. It's positive. Because what is negative 9 squared? And what's the square root of 81? Positive 9. Stop there for a second. I like it. Now, for some reason, students hear me say this. You keep doing this to yourself, John. And what they do for a problem like the ones we just did, they see a problem like this. What's the square root of 25? And they say plus or minus 5. And that don't make any damn sense. But in their head, they have the idea of absolute value, and that kind of messes up with them. No, but the whole point of that says the answer has got to be positive. Okay, I like it. So let's do a couple more real quick. What is the square root of 16? 4. What's the square root of negative 16? Can't be 4 because 4 times 4 is not negative 16. Can't be negative 4 because negative 4 times negative 4 is not negative 16. No. Nope. Not real. See?
It's a negative.
Because it's a negative. So square root can only handle positive or 0 inputs. Because there is no real number that when I multiply it by itself, it comes out negative. If I have 2 numbers that multiply to be negative, what's got to be true about only one of them? Negative. The other one's got to be positive. It's the only frickin' way you can have 2 numbers multiply to negative is if only one of them is negative. And this question is saying, what 2 numbers multiply to be negative 16? What number multiplies by itself to be negative? you're screwed from the beginning. You can't let them be different signs because then they're not the same number. You guys semi with me? Yes.
So it's always negative like that, but if I had to parentheses, squared, that would work.
Yeah, so watch this. You ready? What's the square root of negative 4 squared? This is fine. Why is this one fine? Because negative 4 squared is? What is negative 4 squared? 16. Wow, this is neat. So you can either go that route, or you can do the shortcut of it's the absolute value negative 4, which is 4. Like it says up there. So the output to a square root must be positive or 0. Right? Square root of 0 is 0. The input to a square root must be positive or 0. Right? We will talk about what this is, because notice how I did not say does not exist. I didn't say undefined. I said not real. And this is one of the most tragic misunderstandings of words ever. We will talk about these. Anybody know what these kind of numbers are called? Yeah, that's a shit-ass name. That makes you think like, I knew they were making this shit up and they're finally being honest about this. Imaginary numbers, whatever. I'm sorry, stay with me now. When they first came up with the idea of negative numbers, they thought those were imaginary. Now, are you guys like, does anyone think negative numbers are imaginary? You're college students. You know negative numbers exist. Because I remember being in college, I'm like, oh, bank took more money out because they didn't have any money. I'm negative in this. Okay, thanks, bank. So I knew negative numbers existed that could represent debt and so forth, right? So they actually called negative numbers imaginary when they were first introduced. And then eventually people were like, okay, they exist. We will take away that name. But when they looked at this, they called it imaginary for the same kind of reason, and it never went away. Even when they were like, wait, it does make sense, and shit, everybody's already called them imaginary. But from your perspective, when we start talking about them, I can totally understand you guys are like, what? It's not real, okay? But it's just a bad name. And I do have a video I'm going to show you guys that I did not create, so it has actually good production values. That really kind of explains this. And there's a couple things in the video that I had never seen myself as a student that really was kind of cool. So we'll do that when we get there. Anyway, so if you see right now the square root of negative something, the answer is not real. And we say that because we don't know. We only talk about real numbers so far. We haven't talked about these kind of numbers yet. You guys semi with me?
This course would be dealing with imaginary numbers? Or?
We will eventually. So if you know the answer to this is actually 5i, you can write that down. It's awesome. If you have no idea what the shit 5i is, don't worry about it. We're not there yet. I like it. But, what is this? Negative 9. Yeah, because square root of anyone I can do, and it just says put a negative on it. You guys with me? That negative is not inside. So I do it after I do that. Cool. That's the difference. I like it. But what about this? We're getting way up there in Roman numerals. What do you got, Jeff? Sure. Nope.
Not real.
So I do that first. Oh shit. You're dead. You can't bring that in. Order operation says do this first. Then you can bring the negative. I can't even do that. That. No. I like it.
Is the negative in front of the square root just saying like once you find your answer you divide it by -1?
Multiply by negative 1, yeah. So watch this. What is, you guys remember this from before? What is negative 2? What do I get when I square negative 2? Positive 4. Because this means square, you have two negative 2s. Negative 2 times negative 2. What does this mean? What do I do first? Multiply by negative or raise to a power? Raise to a power. 4, put a negative on it. Yeah. So this is when people come up to me and they say, my calculator is squaring things and they come out negative, Jeff. I'm like, no. You just ain't putting it in there right. Poor little calculator doesn't have eyeballs, thankfully. That would be really strange. So you need to put parentheses so it knows, oh, you mean square the whole damn thing. I like it. I like the look on some of your faces. All right. So, let me see. Let me make sure I do everything in this first section. Here we go. Oh, let's do one like this. And then remind you about domain. Where am I at? I'm all the way up to 8. I love it. What about this? What do you got, Jeff? It doesn't matter. People kind of have an automatic reaction to fractions, but this is, what's that? Square root of 25. What's that? Yeah, so it's 5 over 8. What's 5/8 times 5/8? 25 64ths. All right, so that's the number it takes 2 of to multiply to be that.
Can we see the ugly one?
So tell me what ugly one means.
I mean, whatever you consider ugly.
They're all pretty to me.
I mean,
When I say ugly, I'm just thinking about what's in your head.
just hit it one.
Ooh, we get to 9 now. Look at that.
This one.
You ready?
Yeah.
All right. What about this? Yeah. Do you need absolute value? No, because x squared is always positive already. I like it. If you put absolute value, you're technically not wrong, but you put too much. So what do you think this is? Now watch. This is going to be, what do you think the square root of x to the 10th is? And again, what's the square root symbol ask you? What does it take 2 of, right, to multiply to be that?
6 squared. I mean, x squared.
X to the 5th. I was like, where's that 6 coming from?
6.
So what's it look the square root is doing to the power? Cutting it in half, right? Because that's what square roots do. They cut things in half multiplicatively. Exponents are based on. What are exponents based on? Multiplication. So if square roots cut things in half multiplicatively, and powers multiplicatively, and powers are based on multiplication, they're just going to cut those suckers in half. It's almost too nice to believe. Now watch, real quick. We're getting into this right now anyway. But people often say, like, what's the square root of x to the 16th then? Using that same process.
X to 8.
X to the 8. Careful. But what's the square root of 16?
4.
4. And people say, well, why does it do different things? You know what I would say about this. Is there a 16 anywhere in this problem? No. There's a group of 16 x's. If I cut that in half, I get 8. That's all it says, right? Now watch. You don't have to do this. How do I rate 16? What squared?
4.
4 squared. Square root cuts the power in half, right? So this becomes 4 to the first, which is what the freaking answer is. So if I write a number in exponential form, the root does the same thing to it. If it's not been in exponential form, it's not going to treat it the same way. It's just not in the same form. You guys, some of you guys are at least looking at me. All right. Okay. Oh, so just to remind you guys, we actually looked at this problem before. Actually, before I do this, let me come back to this. How would you start to attack this? See if you guys can develop a process. What is that asking you?
Times 5 times to
Yeah, something that takes 5 of them to multiply to be that. So what do you think should be the first thing you do to that number? Start breaking it down. See what the shit it's made out of, right? So what goes into 243 for sure? 243. 3 goes in. 3 goes into 24. 3 goes into 3. And then 81. 9 times 9. And each 9 is 3 times 3 times 3 times 3. Do you see any, what it takes 5 of? 3. Because that's what it's asking, right? This thing is asking, what does it take 5 of to make this? It takes 5, 3. So what's the answer? 3. A root always cuts a number down. Okay, I like it. Okay, I'm considering, let me show you something. There's always really good analogies between division and root. What's 16 divided by 4? 4. Why? Because it takes 4 4s to add to be 16. So when you divide by 4, the question you could really turn it into is, what does it take 4 of to add to be this? That's what division really means. Do we do that? No, because we develop other ways to do it. Right? But roots, since they're something we don't work with a lot, we start with that way of looking at it. Because we don't have some intuitive way to kind of do it. You guys? Oh, I love you guys. Very often I go off the book, so I don't know, I gotta make sure everybody's with me. Alright. Now notice something about this. What's the fifth root of negative 243? Can I do that?
No.
Well, let's try. I'm giving up so early. This is negative 3 times 81, right? And isn't this negative 9 times negative 9? Right? And isn't this, what do you got? 3 times negative 3 times 3 times negative 3, and I could throw some no negatives in there. So what does it take 5 of to multiply it? Negative 3. And if I have 5 negatives, what will they multiply to be? Negative. Because what does any pair of negatives do? Kill each other. If I have 5 of them, right? So you got people out in the battlefield. Here come the walkers. They die, and they have this one guy's like, I'm still alive. Yes. Are you doing the spot? Okay. I like it. Live long, prosper. We've talked about this before. Yes.
So why can't we do that one even though it's negative, but not the other one?
Beautiful. Because even roots require me to have an even number of things. Bless you. Anytime I have an even number of negatives, what's negative 1 to the 6th power? Positive 1, because there's going to be 3 pairs of 2 negative 1s. They're going to kill each other. Yes, I can see that. Any even power always has the answer come out to be positive, which is why even roots can only handle positive inputs. Odd roots, so I always think about even stuff as being very uptight. For example, could we factor sum of squares? You guys remember this? Can we factor sum of squares? Can you factor sum of squares? No. Right? Only difference of squares. But can you do difference of sum of cubes? Yes, you can. Odd powers and odd roots very laid back. They're like, you're negative, that's fine. You can stay negative, that's great. Even powers and even roots very uptight. I can only have the answer be positive. And that's at least how I look at it. Okay, so watch what this means. If I ask you, what's the domain of this? Let's see, the 4th root again. It's an even root. Is it laid back or uptight? Uptight. Oh shit, the inside has to be what? What's got to be true about the inside? Positive or 0. So at least 0. Remember doing this? We actually had this problem from an earlier section. So the inside must be at least 0. Therefore x must be at least 1. Now let's try it. If you put a 0 in, what do you get? The 4th root of negative 1. It can't do that. That's why it's got to be at least 1. Can't be less than 1.
Is that the answer?
Yes. What's domain again? Tell me, what's the definition of domain? All the x values we're allowed to use. Right? I really want this to make sense. So if you write a math sentence that represents the English idea of what has to happen, if you solve it, that's exactly what x has to be. So only these x values work. If x is 1, what do I get? 0. If x is 2, I get the 4th root of 1. What's the 4th root of 1? What's any root of 1? Because 1 times 1 times 1 times 1, as many as you want is 1. How we doing? All right, so any even root, if I would have put a 14 there, the work is the same. It's just the inside has to be more than 0. Why? Because the root is even. So what if I had this problem? What's the domain of the 5th root of whatever? Is there a restriction on what it can do? We just did the 5th root of 243, and then we did the 5th root of negative 243. Is there a restriction on what the inside can be? It could be anything, positive, negative, 0. So there's no work on these. You just put all reals, you're done. If it's an odd root, it can handle negatives and positives and 0. If it's an even root, it can only handle 0 and positive. And stay real. Stupid dad joke in there about keeping it real. I'm not a dad, so I'm not going to say that. Let's see. We'll close out a little early. Oh, all right. Let's try it here. You ready? What's this? What's the cube root of negative 8? Break it down into 3 parts. We know this from cubes. When I saw the 8, I made it cube 2. So what's the cube root of negative 8? Negative 2. Check it. What's negative 2 times negative 2? 4 times negative 2? Negative 8. So it takes 3 negative 2s to make...
Oh, but it's a positive number, the base, so. I'm confused on the whole why you can do some negatives but not others.
So if it's an even root.
Oh, so it doesn't matter about what's.
So if I ask you, if I say, what do I take the 14th root of to get a negative something? I can't. The answer is going to be positive. But more importantly, what kind of numbers can I put in here? Well, what is anything to the 14th power? It's going to be positive. If I have a negative number,
So long as the number on the outside is
even.
it doesn't matter if the one on the inside is.
So if it's even, the inside has to be at least 0
Okay.
for it to work.
Okay.
Right? I can't do the square root of a negative number, any of those. And please understand, it's just because I can't raise a number to the 14th power and have the number come out negative. I can't. If I raise a negative number to a 14th power is going to come out positive, right? I'm going to have 7 pairs of negatives. They're all going to kill each other. There's no negatives left alive. The minute I have an odd power, which would relate to an odd root, the answer could be negative if it started off negative. Do you guys get that? So what is negative 2 to the 5th power? Negative 2 times negative 2 is 4 times negative 2 is negative 8 times negative 2 is 16 times negative 2 is negative 32. Shit, it came out negative. Of course it did. In fact, you guys see, what's negative 2 times negative 2? Positive 4. That was 2 of them. Times negative 2. Negative is negative again. That's 3 of them. Times negative 2, positive 16. That's 4 of them. Every time there's an even number of them, the answer comes out positive, no matter what the shit it started off as. What does that mean for roots? Even roots can't handle negative inputs because there's no way to have it come out negative with an even power. I like it. So when you see an odd root domain question, it's going to be all reals. This might be pushing it, but why isn't the answer to this one all reals? Is there a problem with the root?
It could be 0.
What could be 0?
The bottom.
Bottom. I love it. So there's no problem with this guy. He's got no issues with anything, but the dude on the inside can't handle it when X is... What makes the bottom 0? 1. So what's the domain of this? X can't be 1. The root had no issues. The dude on the inside had an issue, right? Hey, maybe it's Frankie inside. Oh, Frankie.
What would you write if it was an even square root and then it was the same one? So like it's
Oh, man. That would be, I may not get it to you. You'd have to figure out what side of 1 keeps it positive. It's actually not that bad. Watch, x can't be 1 for sure. But if I make x bigger than 1, that's okay, because I get positive numbers, right? If I make x smaller than 1, I get negative numbers.
Yeah.
So x has to be bigger than 1. You have to kind of think about it. Later we're going to actually see how to do that more algebraically.
Okay.
Yeah. Oh, I keep hiding this thing. All right, last thing. If I can remember what it was, I was going to do. Oh yeah. Where'd he go? Where'd he go? I don't want to do that. Oh, that's it. Last idea. 2 examples. So what is this here?
X minus 1.
Almost. Is that always positive? Okay. So what is this here? Here's where people sort of go off the deep end. I did that one first to give you an idea of what we have to do is square roots cannot handle subtraction and addition directly because that's not what they're based on. Roots are based on multiplication. They're the idea of what does it take to multiply. This is not written in the form for me to think about this. What do I have to do with this first? Factor. I love it. And how's it factor? So like that, right? And now I know what the answer is. Absolute value of x minus 3. Square root cuts it in half, but the answer has to be positive, so that's why I have to stick it in absolute value. I like it. And just to do a little lie, here's the third. What about this guy? See if some of you guys really get this.
Absolute value of X plus 1.
Done. Why? Why? Well, sure, these did too. But I put absolute values because it was an even root. This is a odd root. The answer can come out to be negative. That's why I don't have to save my ass from it maybe being negative. It doesn't matter. It can handle negative inputs, negative outputs. You will start to get this. Just remember, even roots, even powers, very uptight. Odd powers, odd roots, very laid back. You're negative, no problem. Even roots, holy shit, you're negative. Yes.
Odd roots are like the way to go, easier.
Odd roots.